Welcome to Unit 4, Lesson 4, Derivatives of Trigonometric Functions. In the last lesson, we learned about the derivatives of sine and cosine. In this lesson, we'll learn about the other ones, tangent, cotangent, secant, cosecant. Let's start with tangent. To figure out the derivative of tangent x, we have to review trigonometry a little bit. Remember that tangent x, tangent is sine over cosine. Cotangent is just the inverse, is cosine over sine. Cosecant is the inverse of sine, 1 over sine. And secant is the inverse of cosine, 1 over cosine x. There's one more trigonometric identity, so something that we know is true from trigonometry. This cosine squared x plus sine squared x, this is the same as cosine squared x is the same as cosine x squared. It's just a different way of writing it. And sine squared x is just sine x squared. Again, just a different way of writing it. Now, we know that cosine x is, going back to our trigonometric ratios, cosine x is adjacent over the hypotenuse. And sine x is opposite over hypotenuse. So cosine squared x plus sine squared x is adjacent over hypotenuse squared plus opposite over hypotenuse squared. The denominator is the same. The denominator is just hypotenuse squared. So we can add the top. The top is just adjacent squared plus opposite squared. But let's think about this. Going back to our triangle, given any right triangle, given our angle, this is the hypotenuse. Let's call it C. That's the opposite. Let's call it B. Adjacent, let's call it A. In other words, adjacent squared is A squared, opposite squared is B squared, and hypotenuse squared is C squared. It's a right triangle. Pythagorean theorem, A squared plus B squared is just equal to C squared. So really all of this is C squared over C squared, which is equal to 1. In other words, cosine squared x plus sine squared x is just equal to 1. We can also write it as sine squared x plus cosine squared x is equal to 1. We will use this to figure out the derivative of tangent x. Okay. So let's do it. What is if f of x is tangent x, what is f prime of x, the derivative of f? We can use a quotient rule because if f of x is tangent x again is just sine of x over cosine of x. Remember quotient rule? If f is a over b, then the derivative is low d high, b times a prime, minus high d low, a times b prime, over the square of what's below, b squared. Well, in this case, a is sine and b is cosine. Therefore, the derivative of f of x has to equal low cosine x, d high, the derivative of sine x, the derivative of sine x is just cosine x again. So cosine x, minus high d low, high is sine x, d low, the derivative of cosine x. The derivative of cosine x from the last lesson is negative sine x, over the square of what's below? Well, b squared is cosine squared x. Let's simplify. So what we have is f prime of x is cosine squared x. The two negatives cancel each other out, so it's plus sine squared x over cosine squared x. From our last slide, we just saw that cosine squared plus sine squared is 1. So the derivative of tangent x is 1 over cosine squared x. But remember, 1 over cosine x is secant x. So 1 over cosine squared x is secant square x. So that's why the derivative of tangent x is secant square x. Okay? In your homework assignment, you will have to do something similar. Apply the quotient rule to figure out or to prove the derivative of cotangent x. Okay. All right. So using this sort of process, we can figure out the derivative of all 6 trigonometric functions. The derivative of sine x is cosine x. The derivative of cosine x is negative sine x. As we just saw, the derivative of tangent x is secant square x. In your homework, you show that the derivative of cotangent x is negative cosecant square x. The derivative of secant x is secant x times tangent x. And finally, the derivative of cosecant x is negative cosecant x cotangent x. Let's apply these rules with 2 examples. Example 1. F of x is equal to tan x plus cosine x times x squared minus 3x plus 5. Okay? So the derivative, by the product rule, we can do the first term times the derivative of the second term. The derivative of x squared is 2x. Derivative of negative 3x is negative 3. Derivative of 5 is 0. So it's just 2x minus 3. Plus the derivative of the first term. We have tan x. Tangent of x is derivative of tangent x is secant square x. The derivative of cosine x is negative sine x. And then times the second term. X squared minus 3x plus 5. And that's it. Okay. So we're just applying the product. We're applying what we know before, along with the new definitions we've learned. Example 2. G of x is 5x squared plus 3x minus 2 divided by 4 cosecant x. Okay. This time we use the quotient rule. The derivative is low 4 cosecant x. D high, the derivative of 5x squared plus 3x minus 2. The derivative of 5x squared is 10x, because 5 times 2 is 10. 2 minus 1 is 1. The derivative of 3x is 3. So the derivative of 5x squared plus 3x minus 2 is 10x plus 3. So low D high. Minus high 5x squared plus 3x minus 2. D low, the derivative of the bottom one. Well, we have 4 cosecant x. That's 4 times negative cosecant x cotangent x. Okay. So that's all on top. Over the square of what's below. So 4 squared is 16. Cosecant squared x. That's basically it. We can simplify it one further. So the derivative on top would be 4 times cosecant x times 10x plus 3. Next, I see 2 negatives. One negative from here, from the derivative of cosecant x. One negative from the quotient rule itself. They cancel, it becomes positive. 5x squared plus 3x minus 2. We can pull out the 4 in front. And then we have cosecant x, cotangent x. So that's what's on top. Divide by 16 cosecant squared x. I mean, we could simplify it further. There's a 4 on top on both terms, a 16 on the bottom, so I can cancel out the 4 and with the 16, and we end up with 4 on the bottom. Okay, so that's example 2. Alright, that's it for this lesson.